Hi.
Hello.
To the others who want to join.
I hope so.
Yeah, I know that there's a couple of.
Technically, I forgot to add myself to the agenda.
Yeah. Just give me a second. Martin. It's here. There is also. Okay, let's give it a couple of minutes. They should join. Are you, by the way, on the GraphQL team at IBM or?
Sorry, what was the question?
Are you on the GraphQL team at IBM? Like I forgot the name.
Oh my goodness, my connection is very poor. Apologies.
Mine or you? Kamil, can you hear me?
Let me see if I
No.
can switch to my phone.
Unfortunately, yeah.
So is it my connection or is the voice okay? Like,
All good on my side.
okay. Just wanted to make sure. Is that your old flat?
Yeah, it has furniture, so kind of more cozy than the other one.
And Martin also the link. And he also Kamil, very good.
Yeah, I added myself.
You're documented.
Yeah.
Not a host.
I mean, it's merged. It's done.
Shit. Oh. Oh my God.
All right, I think my audio is fixed now.
Okay, awesome. Pascal, John, can you also add yourself to the agenda?
Yeah.
And
Hello.
let's give
Martin.
Yeah,
Martin is coming. He was in the other meeting.
Okay. Yes, it's because we switched to so we used to do these meetings differently. Hi, Martin.
Hi.
Awesome. I think next time it will be like everybody will adapt it to the new.
Yep.
We're doing it with the working group equipment now, like the Zoom channel, it's recorded. We also need to always put ourselves in the agenda, so it's documented who took part and stuff like that.
Yeah, otherwise we're not allowed to talk to each other, I guess.
No, I mean it's open, but it's just
I see.
to document everything correctly. Okay, I think That's everyone. That's good.
Yeah.
So let's get started. Let me remind you, by being here, you all agree to the GraphQL Spec membership agreement, and that we have to add ourselves to the agenda. First things, we do an introduction. We all know each other, but like, my name is Michael. I'm working at Chili Cream, and next on the attendees list is Kamil.
Yeah, I'm Camille. I'm not a host, and yeah, I work at the Guild.
I'm
And
not
then
on the
just-
agenda yet. Should I add
Go ahead.
myself first, or
No, just go ahead.
yeah, I'm Martin. I work at Apollo. I've worked there for a while. And I was one of the creators of the Apollo Federation specification and the products that support it.
Awesome. Pascal?
I'm Pascal. I'm also not a host. I'm on the attendee list in a second, and I'm also work for Chili Cream.
And then we have John.
I'm John Starch. I'm also not a host, and I work at IBM. We're interested in including this in some of our upcoming API standards. So taking a look and seeing how we could do this at scale.
Awesome. Are you just out of interest, are you from the StepSen team, or?
No, we're actually, my team is the Kubernetes service for cloud. So we're trying to figure out how to stitch all of our microservices together, however that looks, and provide a easier development path for them.
Awesome. Okay, let me put, so we have 2 points on the agenda. One is from Martin, actually. And the other one I put on there, but I think Martin also agrees that it's good to discuss that. So the first thing, I want to discuss is entities and keys, get a common understanding, and that naturally flows into composition. Because like we were talking about a bit, and there is a bit of text, so that's not the final text and nothing we have agreed to yet, but we have put together a couple of directives and started a bit working on the composition text, but we have to reshape that now. We had here a section that I put in about around entities and keys, and at the moment we have a text that keys are inferred. So I know Martin is not happy with that, and I'm always okay to change that. I just wanted to have a general discussion around that. So there are 2 things. I in general agree that keys should be explicit. So I also had discussions with Kamil on that, and he also agrees like should be very, very strict and precise, because then you can look at the entity and know what to do. But I also want to have like I would say one exception where it kind of is also explicit, like when the global object identification spec is implemented. In this case, actually the keys are all very specific. In this case, like when you implement the node interface, it is as if you actually write the key on the type.
I see where you're coming from. I wonder though if that's not in conflict with sort of the explicitness in the graphical specification itself, where even though you like implement an interface, for instance, you're still repeating basically everything that's in there. That's sort of what you're expected to do. There's never an implicit inheritance of anything.
Yes, exactly. And by implement, like the interface in the specification is, and I know at larger corporations you have this pattern always used. I talked to, for instance, Mark a bit about that from Netflix. And like in larger setups, you have often that pattern fulfilled. In this case, you already agreed on kind of a key by implementing that interface. And also you have...
Yeah, but I think what I'm saying is that implementing an interface in GraphQL itself never sort of implicitly gives you anything. You still have to implement everything that's in there. So it's I think with keys, there's an argument to be made for a similar mechanism being explicit.
Couldn't we just define the keys on the interface, and if a type implements the interface, then the key is also defined? For example, there could be the case where you, for example, have an interface, I don't know, has name, where you have or has SKU, or just I don't know, product or something like this, where you could have an interface and then just specify the key there on the interface, and then it's still I still see your point, Martin, where in GraphQL you also have to redefine the fields and everything. Why not the keys in this case?
Yeah,
but then you would make it easier to define general key types, if that makes sense.
So
I mean, the idea is definitely to allow keys on interfaces. I think that's something that we agree on. I think the question is whether that would just act as a constraint, so sort of forcing you to then also define that same key in a type, or whether there would be some kind of automatic inference.
Yeah, so the way I thought about it, and that is so first off, like I reflect a bit on what we discussed in earlier meetings, and I think it's good to even you could infer all the keys in cases when we have like entity resolvers. It's good to have them on the type itself, because first, for documentation reasons, where do you look? And second, for validation, because you can now compile time validate if the keys that you expressed are actually also fulfilled by resolvers.
Exactly. Yeah. We sometimes call that double bookkeeping. I don't know if that helps, but I like that analogy.
Yeah. It is exactly that, and I'm on board on that. The one thing I think with this pattern is it's like there's a specification to this pattern, and like this is a contract, but it also has behavior written into the spec. So we have here a specification that is a widely adopted GraphQL specification. And in this case, actually what you can do is kind of, like, let's not talk about implementation details, but what you do by implementing this is actually also declaring here that we have a key that that is ID, right?
Yeah. And I would say I would put this on the interface as well.
Yes, sure.
Like
what it's like, but by implementing the specification, this is kind of implicitly could be implicitly done.
Yeah, I think I was thinking about this not in terms of a specific implementation or a specific specification, but as a general mechanism for like using interfaces as a constraint. So obviously the node interface is a well-known example of that and is sort of a very generic solution. But it would also work for like a product interface with a UPC field, for instance.
Okay.
Or any other hierarchy that you decide to build yourself. That makes sense for your domain.
Yeah, if you,
Not
for
to-
instance,
Not to derail it or anything, but can someone explain key? I've seen the node interface pattern. I haven't seen key
sorry.
before.
Yeah, sorry. We discussed already. We started before the the working group actually started in discussions. So we have the key directive. We have not yet in the spec text. I will add.
It's
that-
part of Apollo Federation, though.
Yeah.
I think that might be a good reference. It's been in
Okay,
use
yes.
for the last 7 years.
Yes,
Yeah, I
but
haven't
we
used Apollo, so apologies.
Let me just quickly go here. Federation.
Maybe
Okay,
I can
so-
provide the totally inexperienced with Federation view.
That's good. Come in here. So you basically have this key directive here.
Yeah.
Which you can put on objects and interfaces, and it in essence describes what keys, like when you have an entity. So what we distinguish between is pure data and pure structured data, which could be an object type, and actual entities. And entities are distinguished in the case that they have unique keys by which you can fetch these, or identify them. And in this case, you basically express this key as a selection set. So this is essentially a selection set without the curly braces. Like you could also write this. And this kind of is a query construct, which is used to identify the fields that we want to introduce in this key here. Like in this case, it's just a single field, but it could also, if you have, let's say, a foo, and this has a name, it can also be misused. I talked about that with Kamil today, where where a customer uses this essentially to send the whole entity.
Yeah, we've seen that pattern as well.
Yeah. Okay. So you can also have this, right? And then this could also be in our composite key by saying, okay, we have here foo, and then we have name. And this means basically that ID and name are our composite keys for this structure.
And you can also have multiple keys to confuse things even further.
Yes. Yes.
Yeah.
Is
In
the idea
short,
with these fields is if you have this key, you can decompose into multiple implementing backends. Two different things can resolve this type.
Yeah,
Yeah.
it's just a traverse between subgraphs. Yeah, so it's used
Yeah.
as sort of an entry point into a particular subgraph.
Got it. Similar to the node pattern, but it's more flexible.
Yes.
Okay.
Yes. It
Thanks.
doesn't have it. You don't have to express like interface. Like the node pattern has a single interface, which basically defines the key of an entity. So basically describes, if you implement that, you are an entity and you have this key. That's kind of what the node pattern does. And then on the query type, it has a field which is called a node, which has a single ID, and then it returns the node, the interface. And if you have this pattern implemented efficiently, like there is a Facebook node on the spec, that actually, ideally you have this one, and then you can do batching. Right? You can ask for multiple nodes in one go. And the thing I wanted to just make clear that is like, but how do you do it today in Federation? Like in Federation today, if I put a key directive on the interface, it's not implicitly inherited, right?
No.
Okay.
No.
So we always do this.
Yeah.
But how do you see that, like with the node interface, because it's such a strong specification? Why I say that is, like, you can give people a very strong, like if you live in these boundaries, you have a very flexible way to define schemas with and you're already abiding to these constraints here. You basically have these key constraints, and if we
I think my worry would be that you're sort of special casing this pattern, which, although it is widely used, isn't like people could define their own node interface, for instance, in their schema. There's no way of ensuring that it actually obeys the specification. And the idea behind like the key directive is that it gives you a generic way of specifying those constraints. It basically tells you what how you're using the node interface, and in this case, it's backed by a specification. But you could use that same mechanism for other interfaces.
Mm-hmm. Yeah, but then you have to put it really on each of the types, which is cumbersome in this case. You're basically quadruple bookkeeping.
Yeah, I think that it all comes down to sort of how explicit you want to be, and I think I usually prefer explicitness and sort of relying on generic mechanisms. But I can definitely see your point of authoring this being a pain. I think the hope would be that your authoring environment or your subgraph library could help you out here. So for instance, if you use like library support for the node pattern, then that could also automatically give you these annotations.
The question is a bit, if you annotate it in the libraries, right?
Yeah.
Then if it's not specified, it's also a weird side effect if it just happens. You know, if you annotate a directive on any interface, a key directive on any interface, and then the library magically adds it to all the implementation, it's a side effect, which is a bit strange. I mean, obviously you could handle it in the subgraph. I mean, we could also have, yeah, but this is also a bit ugly. If we would have a parameter inherited or something like this on the key directive, so that you, if you want, can specify it just on the interface and it's inherited down. And if you want to be explicit, you have to annotate it everywhere. Because if we just make it...
The way I would describe it in a spec is if you use a spec, if we can refer to the spec, then what we do is essentially a post-processing in the composition and kind of annotated.
Is it in the where do you validate this? Do you validate this on the if you think about it, do you validate it on a subgraph level, or do you validate it on the merged supergraph / composed schema thing?
I think that depends on the validation rules you're referring to.
I mean, let's say you would have a validation rule that verifies, in the case that you only annotated on interface, you have a validation rule that verifies that all the implementations also implemented. You know,
yeah,
this would probably the first.
Yeah, that would be a subgraph validation rule, I would say. Yes. because you
Okay,
can validate that on a subgraph in isolation.
Do you also, you don't have to define the keys? Do you define the keys per subgraph, right? You don't
Yes.
define the keys are something which are not shared or required to be shared. So that means that you have to do it anyway on the subgraph, because otherwise you lose the context of it. Yeah.
Yeah, and each subgraph can sort of support their own subset of keys
Makes sense.
on the same
I mean,
entity. Yeah.
Otherwise you would have to implement resolvers when you had a subgraph. So.
Yeah.
Yeah. Let's
Yeah.
Let's push the decision. Let's reflect on it a bit. I will take over the key definition that you originally wrote. I put that in the spec text. Like you wrote a spec text. You remember that? You're okay with me putting it in and replacing the current definition?
Sure. Yeah.
This,
and then we can. Then we can. 1 second. Then we can reflect on this down the line again.
Yeah, I think your suggestion of like considering this a processing step or like a pre-processing step, I would say that might be a possible way out here.
Okay. So I will just take over the definition that we have, and then we are okay with keys, and I also copy over the key directive.
One question about the new key directive specification, or in general keys in Fusion. Is resolvable gone, or is this still in?
What?
Well, I mean, resolvable mainly makes sense when you use the query underscore entities root field as an entry point. Because with normal root fields, you can sort of derive that from the existence of a particular.
Yes, that's why I asked, right? Because you can basically just infer it even with the implementation.
Yeah.
Why?
I think.
Why does this even exist though in Apollo Federation? Because as I read the spec, I wondered what the reason is why this exists. Because when you have on the subgraph, you specify a key and it's not resolvable, there is not really any point of having the key directive at all, or do I get something wrong here?
There are cases where a particular entity, when you're not able to sort of within a particular subgraph to look up an entity by its key, but you still have a way of navigating to those entities from other entities, for instance. So let's say you have a blogging service, and you don't have an arbitrary way of looking up users by their ID, but you still have a way of navigating from a post to its author, for instance. And you still want to specify that semantically, like for instance, the Twitter username of that user acts as a key and can be used to then look up that same user in another subgraph, which does have the Twitter username as a resolvable key.
But you wouldn't annotate this on the subgraph, right?
On both subgraphs, you would annotate it, yes. But one would be resolvable and the other would not be.
But why would you even care on this subgraph that this is resolvable on another subgraph? Because the gateway would handle it anyway, right? Like if you have a username and you specify key not resolvable, this is just an annotation to show that that this might be a key in another subgraph. Or do you require another subgraph to then have a key which is resolvable?
Well, I think that's another question. That sort of depends on our satisfiability step in validation. But key fields have somewhat different semantics from other fields, like they're shareable by default, for instance.
Right.
So that's one of the reasons we want those fields to be marked as key fields in every subgraph if they're there.
Right.
And it also just acts as documentation. It just tells you that, for instance, the blogging service identifies its authors by Twitter username, even though you can't look up an arbitrary user by its Twitter username. You can just navigate from a post to its author, for instance.
I see.
Yeah, let's talk about specifics on the keys. It was more that we have general understanding because you marked that out as some of the points you saw still as an obstacle, right? So I take over the general. I read you had this proposal. I copy over your general specification of keys into the spec text that we have. And then we can discuss the semantics of the things in detail as we go along. I just wanted to get that out of the way. Okay, so the second point was the discussion on the phases of the composition. And you wrote a couple of them. We discussed that. So in general, let me share quickly the email. Second. Because I have some thoughts on that.
Oh, in the meantime, I wanted to share something about the keys. So
yeah, sure. Go
if
ahead.
you hear a screaming baby in background, then it's fine. It's my kid. I'm allowed to. But yeah, what I wanted to say is that with the keys, we need to have, like, if we do those like key directives, then we don't really have within the schema a direct way to resolve an entity. It's an arbitrary resolver, or like, let's call it like an entry point that is like added in post-production. So, you know, with like the query dot underscore entity, right? It's like you have to have something that transforms the schema and adds that kind of logic to it. And if we would use the node object specification, then we kind of have this, let's say, resolver done by the user, which is like very convenient. That's one thing, at least from my side. The other one is that if we would have a way to define the entity resolvers within the query, then it would be also beneficial because then we don't have this like transformation. Then we actually can, like, everything that you want to express or expose to the supergraph, you literally have to write it and you literally have to have it within the schema. So then you don't have something that is like magically added. I do know that it's very, very, very hard to do. We could, like, you know, you could potentially just add an entity you know, field to the query, add a scalar from the federation or whatever, and then by some kind of library add this logic to the resolver, right? It could be, but I don't know. The thing I like about like Fusion, or like the thing that Michael proposed, is that you clearly set the entry points for those entity calls within the query by defining the arguments, which I really like. But I really, really get your point with like being explicit and like having this annotation. And I talked with Michael about it. Is that if you have those entry points defined within the query, in order to be able to like check what are the requirements to actually resolve that entity, you have to like scan through potentially a long list of root fields and see their arguments and analyze if those are really matching, or maybe they could be annotated with something that doesn't really matter. But basically, you have to have some kind of like a process in order to find them. With the key directive, you just go to the key, to the type, and it's right there, right? So I see some pros and cons. Just my main concern is that these like arbitrary things that I added to the GraphQL schema that I'm like not super comfortable with, but I guess if there's not any other way, then it's kind of okay. And from my perspective, like the having like a key field as a selection set, or like inferred from the type, from the fields and stuff like, or arguments, I agree with both. I would say yeah, I don't have like strong opinions there, to be honest.
Yeah, so what Camille just outlined is something like this. When we have entities, where we have these composite keys, and like what is in the proposal now is something that Apollo originally called the finer can I call it finer specification or proposal that they had internal
Finders. Yep.
which basically is the same that we did in Fusion with the entity resolvers. So basically our specs very well map there. The finest entity resolvers basically are root fields. And what I like about them, it's very expressive. You are very much expressing what you want to resolve there, and they're not hidden what they can do. So in this case, when we have here person, we could have a person by ID or however we want to call it, right? And then we would have here, 1 second. And then we would have here a person maybe that is returned, and that would be such a finder or an entity resolver.
Yeah.
We would annotate that to make that clear. And then this could be used to fetch person. So, but in the case where we have now a key, and that's basically also the double bookkeeping, right? In this case, we have this finder down there. We also need to have the key specified. And in this case, it's valid. We have this key here and this finder, so that matches up. So for this guy here, there are a couple of ways to do that. Person, whatever, by ID and address ID or whatever. Whatever. If you want to do them, it could be also like this. An address ID would be also an ID here, would return person, and we could also annotate that. But in this case, already, like, there are difficulties to figure that out. Like, is this key actually what we mean here? Because it's already structural. And then we could hint at that, like in the Apollo's proposal, it was called map. Let's not get stuck on names. We can.
I like is. I like is.
It was Pascal's proposal. So is field, and then we would have here address and could also say ID, right?
Or dot ID.
Yeah, it's I thought about that, but like, you know,
because it's a
why
single field. It's always a single field, right?
I know, but like, wouldn't it kind of mess up people? Like, we tell them with the key that we have this semantics to go to that, which is very GraphQL-y. And what I thought about is that field is actually a field selection. This is a field set, and this is a field selection. And that means you have to select one field and you go from one root field. The pro about this is also like, and this is something we discussed also internally, is you can have keys where this is actually node. Makes no sense, but let's say we have here a node. In this case, I also could have a key where I say, if this node actually is on foo, then I want to have bar.
Yeah.
And if I have, even if I mean one thing, I have to be able to do the same here. So we, and it would be kind of the same instead of the dot syntax. We give the user or the developer one concept to do it. And they could write these double.
Yeah, I mean, it's a bit different from. I mean, I don't know which was the last proposal, but wasn't it a coordinate initially?
The coordinate is not enough. The coordinate is where you say it's this, but you want to say
It's
you
this,
get
but-
to this key. Yeah.
Yeah.
Like if
So
you
this
if you
is
have to,
it always references the person type in this
Yeah.
case, very drill in. It's the same as key essentially.
because the coordinate would be good because you have address, maybe address 1, and if you just say this is an address ID, so which of these fields you have to use. So we kind of like this is a good way to do it. Like there's also another thing which I would add to this, because like if we have, like this is fine, right? This is fine if we talk about 2 information. But what if we talk about the abuse that I called out in the beginning, where people actually want to have more information in this? And this is where actually you could have something like this, and then use an input. So an input type.
Yeah.
For instance, person input for this use case, like it could also be some random input key type or input key type, whatever you call it. Okay. So in this case, like, and I haven't worked through all the issues here, right? I'm just putting a bit the thought out around these.
Yeah.
So we have the person key input here. So we could take these guys and just align them. And if we want to keep the structure, we could also have, like this could be nested. Let's keep it simple. And that could be address. So there's one obstacle here for the keen-eyed graphical users. Right, this could be our input here. And like, so we have to have some annotations here. We could use is with a second field or whatever, or whatever. We have to figure that out. As I said, it's not fully planned through, but this would work out if we kind of say this is like in this instance we could use a coordinate, or but as I said, this is not. So don't chastise me for. This I could use graphical coordinates or whatever.
Wait,
and
what's
then,
this doing?
So
why is it referencing person? Isn't that already the return type? Like, why would
Yes,
this
you're
reference
right.
person?
We don't. You're right. We don't need that. You're right.
Yeah,
It's-
but you
it's
still need to define is, because the problem that you have here is different. The person key input has to be annotated here. It has to be annotated on the entity resolver. You cannot annotate it on the input type, and you cannot annotate it on the input fields, because the person key input could be used in a field which returns address. So you have to annotate it in the resolver.
because you could reuse it if you wanted.
You could reuse it, exactly. So you have to define in the entities resolver what this stuff refers to.
Yeah.
I mean, this is something you run into many issues with this, right? Because the structure has to be equal, otherwise it will not work.
Yeah. What I wanted to also this also works, by the way, for these fragment cases. So you could even get it to work for these fragment cases, where we could now do foo or person, and then we use one off. And in this case, you have it's not worked out, Pascal, but it is possible. Like, because that was one of the obstacles we thought about when we thought about inputs. Like,
Yeah,
I see
CQRS
biggest
people do stuff like this all the time, where they I wouldn't say abuse, but they're so into CQRS that they use GraphQL as their vehicle of choice to do their CQRS, and then sometimes they have these request inputs on query fields as well. I personally don't like it, and then you would be a bit doomed if you could just map fields, obviously. Though I would say we could push this also a bit down the road, because that has so many complications.
I just want as I said,
it's not.
Yeah,
it's definitely helpful to put some thoughts in my head. I think describing these edge cases that you've been thinking about, that's helpful, I think. But
and as I said, it's not we haven't figured out all the problem cases, but this is where we were thinking around.
I guess the only way how you could make this work is when you would annotate on the person key input type, for which type the field is. For example, you would say is ID on coordinate person is address ID on coordinate person. If you would do this on the input, then you could basically have any structure you want on the input object, and you could always map it to the entity keys. Though, as said, it's complicated.
Yeah. Let's not get stuck on it.
There are some interesting other directions, I think, that we could talk about at some future time. But using aliases, for instance, and some extensions of selection set syntax, that might be a good way to specify the mapping at the root field level, even for multiple key fields that map to different parts of an input type or traverse input types.
Yeah, but then you have a slight issue. What do you do if you scroll up? Aliases. I thought also about aliases, but what do you do when you have nested things? You know, when you have a key ID, address ID, the second one, the second key on line 7. If you have this key, you cannot really express this with an alias, right?
It would be an extension of the normal selection set syntax, where basically aliases can be followed by like dot paths.
Let's say there's also, we could also have a look at there are some spec proposals for aliased
selection sets.
No, aliased fragments. But let's not have a look at that. I don't want to capture all the times on keys and go also with the rest of the times into composition, just so that we because Camille ventured into this. This is a lot of discussion, and I think we have a lot of work to do on that to get it working. Okay, so with that, let's start talking about the composition phases, because that was actually where we left off last time. And Martin already outlined them. If you want to explain, Martin, you can go ahead, because it's from you.
Sure. So the way we currently perform sort of composition and look at composition is in terms of 3 stages. And these 3 stages have sort of their own validation rules and their own what you might call success conditions. So the first one is subgraph validation, and that's really about validating each subgraph in isolation. And first of all, that makes sure that it's a valid GraphQL schema, just applying the normal GraphQL schema validation rules. But obviously there are additional validation rules that we require on top of that. So for instance, our federation directives have specific semantics those need to be checked. So for instance, if there's a key directive on there, from the perspective of GraphQL, the fields argument is just basically a string. It's or a scalar. But we want to validate that it's a valid selection set or field set, as we call them. We also want to make sure that the fields that you mention are actually defined in your schema. So these are all things that you can validate per subgraph. If this stage doesn't pass, there's no sense like going on to the next stage. Like you want to make sure that each subgraph is actually completely valid before you go on to the next stage. And then the next stage is about merging these subgraphs, and the end result of that should be what we call a supergraph, which is basically a merged representation of a set of subgraphs. So it's not just the sort of externally visible part of the supergraph, which we call the API schema. It also contains fields and potentially types that are just used internally. It also contains metadata. But what this ensures this stage is that that merged supergraph is actually valid. That means it has to be fully consistent. Like for instance, you can't have different subgraphs defining the same field on the same type with a completely different type that's completely incompatible. That would be a hard failure. Like there's no way to generate a consistent representation of a supergraph if those subgraphs have completely different field definitions. But there are other cases where, for instance, one subgraph defines a field as nullable and another defines it as non-nullable. We can still generate a valid representation in those cases. And we have specific rules that sort of tell us what sort of direction we favor, which is somewhat different for inputs and outputs. But it's trying to be a little bit lenient, and we generate warnings in most of these cases. So those are still things that you might want to take a look at and potentially fix, but it doesn't sort of block the generation of the supergraph. And then once you have a valid supergraph, the next stage is a fairly thorough validation of what we call the fundamental property of federation. And sort of informally, what that's saying is that you want to make sure that from a client perspective, the API schema that sort of represents the supergraph acts as a normal GraphQL schema. So every valid query against that schema should be resolvable, should be satisfiable. So it means that we actually validate, and there's sort of a more formal definition of this, but we basically go through every type and every field in the API schema, and we make sure that there's a way of navigating to it. It's a fairly exhaustive traversal, basically, of what we call the full query graph. I think Camille has been implementing this in the Guild's composition library, so he might have something to say.
Yeah, I have
but
like
this-
10 more gray hairs every single time I write some code about it, but yeah, it's like really tough.
It's basically like a graph traversal problem, and it's really hard to do it efficiently. But it's sort of semantically, it's the only way we've found to really nail down this fundamental property.
It's a directional graph because you always have the root and where you come in.
Yes.
Yeah, I agree. And the main problem why this is a problem is actually because it provides what makes it more complex and requires.
Yeah.
But because you have these additional, okay, when you come through this path, you actually have this capabilities. But if you come through the other side, you might lack certain things.
Yeah,
Yep.
I would say for this, I guess this would also have helped you a lot out, Kamil, is that you would have a good spec which you can use to verify your implementation. And I say this because this is something that will should definitely be in the sense of the algorithms that we have in the graphical specification. But as long as you have the same output, you can do whatever you want.
Yeah.
Because I see here that a lot of implementation will do it differently because it's an exhausting algorithm. So someone has a good idea and want to make it, I don't know, 200 times faster, then go ahead, as long as it satisfies the rule that is defined in the specification. But it should definitely be something that should be specified in detail so that you have a way to verify that what you did actually works, right?
Yeah, general. Doesn't have to be like that's also something that we always do in the graphical specification. It doesn't have to be the fastest algorithm. It's more important that it's concise to understand.
Yeah, I mean, looking at this this proposal with these validation steps, I guess that makes a lot of sense. I mean, we've seen this also by writing the initial fusion validation rules and merge rules, right?
Yeah,
so you have different steps.
Yes, and this is very simple. This is fairly simple. And this is really the most complex one.
Yep.
I
mean, it is complex, but at the same time,
it's hard to make it.
It's only one rule. So
Yeah.
instead of having like a whole set of very, very specific rules that would somehow ensure this property, it's sort of a direct description of like the constraint, basically.
Yeah, I mean, it's just hard to make it fast.
Yeah,
it's an easy rule when you have time. But when you have to make it fast, it's hard, right? Because you have to do it. The easiest thing is to just verify each property on its own and just traverse the whole graph and see if it's possible.
Yeah, and I mean, and there's various heuristics that you can apply, and you can obviously like implement things more efficiently and cache things, or come up with more efficient data structures. But it's still a hard problem.
Yeah. I guess it goes into direction of the which rule was it? The graphical specification headache rule.
The field merging algorithm. But the field merging algorithm is simple compared.
Yeah, it's simpler. It's simpler, but
yeah,
it's also annoying.
Yeah.
Yes, it's one of them. Okay, so in general, I think just in general we have these kinds of so there's two things I'm thinking around validation, right? When we look at the first two steps, this subgraph validation and the merge validation, like here are certain validation rules we can formally specify. We don't have to have the full algorithms for how you want to implement that, but more like, okay, this is, for instance, the rule to merge the type, and this is what is not allowed. So we started on that a bit. That we have here a validation section. Like they don't fit all on this. We have to kick some out, put some new in, so that we have all the things that we have now for directives. But the general ones will also fit, like the general like type kind validation and things like that. When we look at the merge rules, the discussion that, or the thing I was thinking about a bit, is how we structure it. At the moment, we have a big validation block, which actually is a combination of the subgraph validation and the merge validation. So we basically called out, this is what you need to validate. We didn't put them in these phases. So we basically had validate and then compose. And compose was the part that basically merges this stuff together and outputs it. And at the end, you have this subgraph, which is not fully validated because the last part is missing, right? So you have the validate. The validate, as I said, also calls out the things that you should have validated in the compose step. Can you follow, Martin, on what I mean?
Not completely, no.
Yeah, so in the compose algorithms, what we did there is basically describe the actual merge. So how do you put the schemas together?
Yeah.
This doesn't look into validation. It's just the algorithm. So how do we merge, for instance, an object type? To merge an object type, we're gonna take type A, type B. It's a very similar language to how you do it in the GraphQL spec language, and then you basically, this is how you merge it. Whereas we have under validation, we have then the rule type semantical equivalence, for instance, says that types are not even mergeable, so we cannot go to the merge step if they don't match the kind. For instance, this would be allowed, these merge, these could merge, but if you have a user type and a user scalar, this would explode.
Yeah. That makes sense. I wonder if it would make sense. I mean, I think the merge rules are definitely a necessary part of the specification, something that we didn't discuss before. I wonder if it would make sense to sort of per stage specify both what, or for instance, for that merge stage to specify both the merge rules and the validation rules, and then in an implementation you can sort of interleave them if you want.
We can,
if that makes sense.
We can definitely do that. It's more, I suppose, more up for discussion, because at the moment we kind of have a big chapter validation. Yeah, and then we describe all the validation rules for all of it, and then we basically leave it up to the implementer how they're going to implement it. Do they validate the subgraphs on their own, or is it implemented in, okay, here are the 5 subgraphs, and then they do whatever? We just called out the rules that you have to make sure.
The thing is a bit that sometimes in some rules the context is important. For example, when you validate that the keys are satisfied on a subgraph level, you cannot. I mean, you can merge first, but then you have to still have all the information about the subgraph, which you do have in the compose graph with all the.
This is one of them, Pascal. Yeah, this is one of them where we basically let type name be the set of all type names across subgraphs, right? You want to build this set of types across the graphs and then check if the types from the kind match. Yeah. That makes only sense in the second step.
I think also like one of the goals of the specification, and I think the GraphQL specification does a good job there, is sort of its understandability. It's sort of helping you understand the requirements. And I think they're describing the different stages, and also before going into specific rules, sort of introducing the stage, sort of describing the purpose, the outcome, and then going into specific rules.
Having this introduction, you can also line out what is available in this stage. For example, in the subgraph stage, you have no idea about any other subgraphs. So when you type a validation rule, you cannot say, is there on the other subgraphs some kind of type with this name? If you write a subgraph rule, you do not have this information. If this is specified as the boundaries of what your rule is, it's really easy to validate new rules. You just read it and say it doesn't work. And second thing is that when you have these boundaries specified, you guarantee that you can validate the first step without having to do any other work, because that makes the first step really simple, right?
Okay.
And also the next stages can then sort of rely on those first rules being satisfied. So for instance, like you would never get an invalid key once you're at the merging step.
Okay, so then agree. So then, like at the moment in this composition chapter, we also have the directive specified for the subgraph. I think let's restructure it. I'll introduce a new section here for the subgraphs, where we put the directives in, and then we describe a bit what the subgraph is and stuff like that. And then we use the composition chapter, and we basically introduce here the phases that we have, and within the phases we have a validation section, then the algorithm section of what is actually the merge process. Basically like that.
That makes a lot of sense. I'm also happy to, because I do have some. Well, I mean, you also have the version that I sent you. There might be some text in there that we can reuse.
Yes, that's why I said earlier I will copy over the entities and keys section from you.
Yeah, but also there's a description of sort of what, like the subgraphs and composition.
Yes.
I'm also happy to expand on the description of those stages if that's helpful.
Yeah.
But let's.
Yeah. So let me put in an empty chapter for subgraphs. Move over the directives. Then then I squash everything in here. We make a clean proposal branch, and then we can all work with pull requests against that.
Yeah.
Sounds good, because then you can also just it doesn't have to be me who does all the definition work or so. Then we can all independently also make just PR proposals. Sounds good.
Yeah, I can try to put something together for the next meeting.
Yeah.
In a PR.
So what do we want the stages to be named? I'm just making notes. So the first one is the subgraph validation, or the subgraph.
Yeah.
Third is the merge.
Yeah.
So this we called out in the last discussion we had, Martin, was satisfiability. I don't know if it's a good name.
I don't know either. I'm open to other suggestions. It's sort of what we've been calling it, but happy to think about others. There's one other thing that I don't think we have in here yet that I just thought of. We also have sort of a formal description of how you get from a supergraph to an API schema. So basically how you filter out the things that should not be part of the client schema.
Yes.
I think that might also be something that we would want to put in here at some point. So I wonder how that affects the structure.
Are we talking about? Yeah,
it's inaccessible.
Are we talking about tags or?
No, the inaccessible.
Yeah,
directive.
It's inaccessible, and there are some other possible like. When you think about propagation of metadata, for instance, some directives might be just used internally and others are
you're right.
Potentially useful for clients. So it's sort of what we've been calling the API schema. So we differentiate between the supergraph schema and the API schema. And then the supergraph schema is just this like internal representation of basically the entire merged graph.
Yeah,
with all the internal metadata on it. And then there's something that represents the schema from a client perspective.
Yeah,
Yeah, and
it
it
the
also-
we call it the public schema in Fusion, but it's
It
the
also
same.
requires like set of validation rules to check if this inaccessible thing is not like used and stuff like that by the public schema. So it kind of has its own validation phase, I would say, but it could be done at the supergraph level. It
Yeah, I
doesn't
would
have to
say-
be at the like filtering whatever or like generation of the API schema.
Yeah,
So-
I would say this doesn't the satisfiability validation, I would say satisfiability is just one rule there, right? You probably have other rules. Now you can say where you want to have them. You could do this validation that the public schema is actually valid because you, for example, ignored an interface or whatever. That you can do this validation. You could do this on merge, but technically probably after merge makes more sense. So it would be in the same category as the satisfiability validation. It's more like when we remove all the internal inaccessible stuff, then the schema should still be valid. I
But
guess
didn't we do that in the merge phase? Because like the inaccessible, like that, like yeah, we have that under the validation rules, right?
It's
that
technically
if
it's
you-
technically
if-
possible to do it in both. You first merge and then you validate.
But why would you do that? I mean, like I remember we had discussions on that because like what the danger is that you have empty object types, for instance, when you remove all the inaccessibles or internals.
Yeah.
But this you already have in the merge.
I actually have to go in a few minutes.
Yeah, we can go.
yeah.
So I do I just reshape it a bit.
Yeah,
I think there's
the only reason I mentioned it was because it might affect the structure. So it's just something to keep in mind when we think about this.
I also replaced that with the foundation copyrights and stuff.
Yep.
Kick that everything out, and I think then I squash it into a working branch, and then we can work in pull requests because then we can also better track.
Yes, that
That
makes a lot
sounds
of
good.
sense.
Yeah.
Okay, I will do that. Okay, so with that, we're done, and then we can pick it up next week. Was a good discussion, I think.
Yeah, definitely.
Okay,
Thank you so
see you all.
much. All right.
Goodbye.
Bye.
Bye.